Hello, my name is Nicholas Boyd, Senior at the University of Pittsburgh at Bradford, and today I will be presenting to you my capstone project for the fall of 2019. My capstone project is a digital calendar to help replace old paper calendars that have become obsolete due to technological advances in the past years. The idea stems from at least my family always used to having an old paper calendar hanging in the kitchen, and it kind of becoming a thing we don't do as much anymore because we all have our calendar on the phone, on our computers, and we generally just don't like writing stuff down on a paper calendar anymore. It gets cluttered and it gets messy easily, and we forget to change the date. So I solved that issue with creating a digital calendar to help modernize the paper calendar and offer a lot of unique features that you couldn't ever get on a paper calendar. So my project had two different things I had to deal with, both hardware and software. I will be describing the hardware portion first and then moving on to the software. So as you can see, this is the digital calendar. This is what you would look at or mount on the wall. And to describe the hardware, I'm going to flip it over to the back to start talking about the internal components of it. So in the back, the whole thing that runs this digital calendar is a Raspberry Pi 4, 1 GB model. So I decided for this project the Raspberry Pi was a perfect solution for this project because of its size. It's the newer Raspberry Pi 4 model can go up to 4 gigs. I choose 1 gig because it was all that was available. It had these GPIO pins to add your own inputs, which are these buttons, which I'll get to. And it overall was the perfect solution for what I needed to run this calendar. Moving on, I have these two momentary push buttons that are connected through just some wires I soldered to the Raspberry Pi board. And as you can see, hopefully, the pins are right here. They connect right to the back of the buttons. I move this. And they cause different actions to perform when they are pressed. Moving down, this is a monitor. It's an old HP compact monitor. It was flat screen that I broke out of its casing. I moved this back panel down. It was originally more center of the screen, but I had to move it down to the corner so I had room for the Pi and some of the cable management. I have a VGA to mini HDMI adapter. The monitor is probably at least 10 years old, and the Raspberry Pi is from the summer, so different technology, needs different inputs for videos, of course. So I had to get an adapter to adapt the monitor's VGA input to the Raspberry Pi's mini HDMI output. I also have a mini power brick. Right here. This is an 8-foot long power cord, which can be coiled up and hidden right here if there would happen to be a outlet behind the calendar that you can mount, where you mount it, or you can let the cable come out here through a notch that's right here and go to almost anywhere you need it. Inside this power brick is connected to this power brick is the power cord for the Raspberry Pi and the monitor. And the only other piece of hardware, which is more ancient than any of those other ones, is the actual wooden frame. The wooden frame is a design I built myself, where I custom measured the dimensions to fit this display. The display, if you can kind of tell, there is a little crease there. The main part of the frame is one piece, and there's this front cover. The display sat into the front cover through the use of these here and here. There are these railings. The display sat down flush with the frame, and then I covered up the front panel with this cutout I made. And then I painted it with a gray paint just to make it look a lot nicer than plain wood. So that's about all the hardware. Now I'm going to show you one of the functions of the buttons I talked about earlier. So we have two buttons here. Two buttons here for interacting with the Pi, because one of the features of the Raspberry Pi is it doesn't have a power button, and there's no way to turn on and off this display now that it was broken out of its housing. Normally with these displays, you'd have a little button in the bottom corner where you'd be able to turn on and off the display as needed. Because I lost that functionality, I decided to add it through my own. So, starting off with the buttons, we have the first bottom button. The bottom button is the button that turns on and off the display of the Pi. That actually works with turning on and off the HDMI ports on the Raspberry Pi 4. Because when we busted out the monitor, again, we lost the power button for a monitor that would normally do that, turn on and off the monitor itself. So, when we press the button, it turns on and off the actual display, or the HDMI ports. With this script, you have to wait 10 seconds between turning on and off the display because the script works in a loop, which I'll show you in a minute. So it's been about 10 seconds now, so I'll press the button and the display will turn on. And to show you that code, I will transition to desktop, just full screen it, and we'll go to display button. So it's like I said, it's a loop. It's a Python script, first. It's a loop. It looks for the input of the GPIO pins, which the buttons are connected to. We check the sub output of the current setting of the HDMI port, which is either 0 or 1, which is on or off, dealing with binary, and basically an easy if-else statement. If the monitor is on, turn it off. If the monitor is off, turn it on. So a very simple button with a good output that we have seen here. By turning on and off the HDMI ports, the display itself turns on and off. So that was very simple and easy. Now we got the second button, the power button. So the power button turns on and off the Raspberry Pi, which deals with both a script and an exploit. So to show an example, I push the power button, the Raspberry Pi initiates shutdown and turns off. And while there is no time limit on this script of restraining how often you can use it, it's better to give it about 10 to 15 seconds to let the Raspberry Pi actually shut off before turning it back on. That is just general computer nonsense. So if I hit that button again after a little bit of time, boot takes somewhere between 10 and 15 seconds before everything's completely done. It is probably due to the fact that the Raspberry Pi's operating system is stored on a micro SD card, which doesn't have probably the fastest read-write speeds out there. So as you can see, the Raspberry Pi is booting, and you'll actually see another feature, which is the website turns on and off automatically. And one of the problems of the website, as you just saw there, is that by the time the Raspberry Pi is booted, the Wi-Fi hasn't quite connected yet, so it says it cannot load the web page, but if you give it a second, it eventually loads. Now the power button, I'll show you the script for, like I said, deals with both a script and an exploit. So transition back to the desktop, go back to here. The power button has a lot less code than the actual display button. So like before, we have the GPIO pin looking for input from the buttons. It is in a loop because that's not how this functionality works, so there is no while true. And basically, when the GPIO pins see an input, it initiates subprocess shutdown-h-now and shuts down the Pi. Now, the problem comes when doing something like this is how do you turn the Raspberry Pi on? So when your Raspberry Pi is off, there is no way to execute a script. The computer is off. So how do you get the Raspberry Pi to turn on? So to make this happen, we actually play with an exploit of the GPIO pins. GPIO pins 5 and 6, when shorted through like a button, actually boot the Raspberry Pi. This makes the functionality of the power button completely possible now. So when you want to turn off the Pi, you have your button plugged into pins 5 and 6. You hit the button, and while the pin's short, the Pi is already on, so nothing happens. But what actually happens is the script now executes and the Raspberry Pi turns off. When the Raspberry Pi is off, no scripts can run, so the only thing that happens is a short between pins 5 and 6, and the Pi turns on. So the whole power button deals with the principle of scripts working and shorting not working to turn the Pi off, and when the Pi is off, scripts not working but the short working. It is a good exploit of the Pi and allows a nice power button, which is a function the Raspberry Pi does not have, and lets the users actually turn on and off the Pi if for some reason they would need to. So, moving on, talking about what is actually being displayed here. So what's being displayed here is a web page I built and being hosted on an Amazon web server. The Amazon web server decision was for the fact that if I wanted to make another display and the website was hosted locally, I would have to then copy the files over, make another local host, and host the web page on that Raspberry Pi, and then none of the information between the calendars would be shared. Because I have this calendar hosted in the cloud, I could build an infinite amount of these displays and actually display the same web page over and over and over and over again, and all the events being shown over and over and over again. And if I add an event on this calendar, it would go to every other calendar. On the web server itself, I have Apache that's actually hosting the web page. I have a PHP module that actually lets the PHP run on the web page, and I have MySQL for the database. The web server is running Windows 2016 GUI. It made the project a little bit easier for me to be able to modify code on the web page, modify the database through the GUI, and just deal with stuff. So to actually talk about the website, unfortunately through the glare on the screen and the zoom, I'm going to transition to my desktop and bring up the web page in Chrome to talk about the different functions of the website itself. So switch to the desktop, go to Chrome, and first we'll talk about the top, and we'll work our way down. So at the top we have a good afternoon message. There's 3 different messages that will appear based on the time of day: good morning, good afternoon, and good evening. When I go through the code of the website, I'll show you the different if-else statements of how that works. The next part, we have a general message. It is time on the date of month, and this is just a message that will update based on what time and day of the year it is. The message does not refresh, but if the web page refreshes, the message updates. So like on the calendar itself, I have the web page update every minute or so. So the time is never more than a minute off, and the date doesn't really need to be refreshed ever other than once a day. Down below that, we have the quote of the day. The quote of the day is a PHP function that pulls a specific quote out of my database quotes based on the date. So each day you have a different quote. Today's Wednesday, 27th of November is "Let this video presentation turn out well." Tomorrow it'll be maybe something like "Happy this presentation is over already." Quote of the day, I'll show you, just pulls from a database. It's not a very complex script, and that's about it. Moving down below, we have a weather function, which is actually just embed of a weather app that I pulled from a website. It is weather.com, I believe. It was easier to do this for weather because they automatically send the updates to these embeddables to like what the weather is, and it just was an easier solution than trying to make my own weather app. The only issue I have with this weather app is it pulls from a location where you have to manually set rather than actually are. So right now I'm in Newville, Pennsylvania, but this web page is telling me the weather for Bradford. It would be a version 2 of how to pull from current location, but that is not what I was able to get through in this project. Down below the weather, I actually have a news ticker. So if you imagine at the bottom of the news every night, there's the headlines of what's going on and what they're talking about or already talked about. This is basically what that is. It is a scrolling news ticker that pulls from an RSS feed. This current RSS feed is CNN World News, and it pulls the top 10 articles or headlines from that RSS feed and displays them in a scrolling function. The RSS feed is set to refresh every 10 minutes and pull the next set of headlines. The RSS feed doesn't refresh with the web page, it refreshes with its internal refresh. So as you can see, Manchester City owners worth nearly $5 billion after Silver Lake deal, and the next one, top bank CEO down something. It continuously scrolls, and the RSS feed can be changed based on user's preference. So moving down a little bit more, we have the actual calendar itself. Now the calendar itself was a problem with the project. I have it implemented and almost working, but I cannot actually get the events to load or not load in the calendar, or else I would actually have some events to be visible. So to start off with the calendar, you're able to change months based on that, on what month it is, and clicking through the months. The calendar automatically updates when the starting day and the end day of the month is, so it is not manually set that November is 30 days starting on Friday. If you continuously click through, the calendar pulls data from sources and actually creates its own calendars to create them and have them be accurate. So clicking back to current, we have 3 different views of the calendar itself. Also, we have the month, which is the big month view. We have the week view, which shows you hourly things. So you'd have events that would go from 8 a.m. to 12 p.m. and it would just show you the weekly hourly setup. And then we have the day, which is just one day. So November, this one's for some reason showing November 1st. If you click through, you get each day, what day of the week they are, and move on. So the calendar should work by clicking on whatever date you want, putting in an event test, and then the date format, which you have to go off the date format of the MySQL date format. So it would be 2019-11-27. So that would be the start of the event. So if we wanted it to go for a full day, it would be then 2019-11-28. By doing this, you're basically saying the event test goes from the 27th of November in 2019 to the 28th of November 2019. If you'd want to add specific hours, you just add them in military format at the end. So you do 00-01-00. But if you don't put any dates, it'll default till midnight. So when you click this, it should add the event successfully to the database and then display. However, it does not, and I have not been able to troubleshoot that part of the project. If I do this project over again, I'd use some different calendar app, maybe one that's set up already like Google Calendar, which is what most people recommend when I was looking up this project of what to do for calendar. It said use someone else's calendar because they already did functionality better than you can probably do it. So that is the website, and now I'm just going to go over the code real quick of all the different functions of the calendar and just the layout of the website itself. So to do that, I'm going to be heading back to my Amazon web server and go through these functions. So like I said, there's 4 functions of the calendar: the insert, update, delete, and load functions. Going through them quickly, basically they connect to the database that I have set up for calendars, and it executes just different queries. So we have insert into events for the insert based on the values you put in. You have load, which connects to the database and just pulls select star from events by order ID. So it pulls all the events and puts them into the calendar just for them to be displayed. You have the update, which lets you change if you have something set for the 27th at 6 p.m. and you actually realize you need it to be at 7 p.m. It lets you modify the hours and have the event parameters updated. And then finally, you just have the delete, which lets you remove an event from the calendar if needed. Moving on to the actual website itself. Sorry, scrolling up here to the top. It is a PHP web page with HTML within the PHP. This just lets all the PHP scripts work. To start off with, we have the background image. As you probably noticed earlier in the video, the image changed every time the page refreshed. This is because I have 5 different pictures in an array, and one picture is chosen at random from the array to then be displayed. Moving down in the head of the document, we have all the CSS and script pages in there. In total, there's a decent amount based on all the different scripts and functions they have in there. Also, we have the calendar functions, the insert, update, delete, which is actually where it asks you to how you want to modify the event or add in the event or delete the event, and so on and so on. Moving down, we're actually at the start of the website itself. We have the greeting message. So like I said, I'd show you before, the good morning, good afternoon, good evening is based on an if-else statement. So if it's between the hours of 5 and 11, you get good morning. If it's between the hours of 12 and 18, you get good afternoon. And if it's between the hours of 19 and 4, you have good evening. So just a simple greeting message based on the time of the day, which is pulled from up here from American New York, which we're on. And that. Moving down, we have the welcome message, or we have the informational message of it is like time on the certain date. Simple PHP message, not much to talk about there. We have the quote of the day. We have just a simple PHP statement to connect us to the database and retrieve the quote based on the ID, based on the date. And echo quote of the day is quote. Moving down, we have a small section for the actual weather. Again, it is a embeddable link I got from a website from an actual weather source. It was pretty simple to implement and not much code on my part. Then you have the news ticker, which is mostly stored in some JavaScript files, not displayed here. As you can see, the UL, which is the scrolling wheel, is actually has the information inputted from the JavaScript, which I won't be going over. Down here is the actual settings of the ticker, like the RSS feed, the feed count being 10 new news headlines, and the refresh being every 10 minutes, which is how it actually pulls information from the website. At the very bottom, we have the calendar, which is again all the separate documents that load in this calendar information for it to actually display accurate months and a format of a calendar that would look similar to a paper calendar. And for the background image, we actually have to put the CSS inside the actual website itself, due to the fact that the CSS actually has a PHP script small in it, so PHP echo random background. If I'd put this inside the CSS page, it would not be able to execute because it would not be able to run PHP scripts. So I did have to put this styling inside the PHP document of the website, and it is the only thing. So there's 2 main CSS pages I've had to use for this website. You got just general setting text size and color. I went with white text with a black border because if you didn't know, white text with a black border can be seen on almost any color, or basically every color, and it makes it easy. But there's not much going on with the CSS page, just general font and font color choices. Over here we have the news ticker CSS page. It needed a little bit more stuff and filled up my web pages CSS page a lot, so I just separated it into a different page, and it basically just deals with more setting margins and paddings and text decorations and positions of the ticker and how the actual ticker looks and stuff, which is basically it, just general stuff. So that's really all the code I have in this project. There is more, but to go on would take forever. Problems with the website, of course the calendar didn't work. I wish the buttons would light up. Every once in a while, whenever the page refreshes, it freaks out and doesn't actually display the web page. It gives me an error message, aw, snap. I think it's a problem with Chromium and how that is all working. But that is my presentation for my capstone, and I hope you enjoyed. Thank you for watching, and goodbye.